I would like to start off by thanking you all for your time today. For those of you who don't know me, my name is Jen Fuentes, and besides being the most awesome resource that CMG has to offer, I am also one of the IT solution advisors. For those of you who've attended our previous webinar on DevSecOps with our sister company, Critical Design Associates, the content and the demos will be completely different. On the first few slides, some of the content will sound familiar, but the demos and rest of the presentation is going to be all new content. Before we go over the agenda, I'd like to quickly introduce two of the coolest guys I know, and no, they did not pay me to say that. They probably should have. Joining me today, we have Anthony DiDonato, and not only is he the founder of CMG, but he is also one of our principal architects. In addition, we have Tom Wilson, who is our Senior VP of Pro Services. And even though I did say these are the coolest guys I know, which they are, that's enough about them. Let's get into the cool content that we're going to cover. In today's presentation, you can expect us to review the business value DevSecOps brings to your environment. I will quickly cover the difference between DevOps and DevSecOps. I'll go over some helpful terminology, building versus buying. Of course, in between, you will see some pretty awesome demos, and near the end, we will recap the content and the value of DevSecOps in your environment. Tom will briefly discuss some of the CMG services with you, and I will share our upcoming webinars to be on the lookout for. At the end of our presentation, we will have an open Q&A session where you'll have the opportunity to ask our resources any questions you may have. But should you have any questions throughout the presentation, please don't hesitate to put it in the chat. Businesses who engage in DevSecOps approach can expect several benefits. We are able to reduce downtime by having rapid recovery components built into your CI/CD pipelines. You have the ability to automate those repetitive, mundane tasks, reduce shadow IT by delivering faster, produce repeatable results, as well as the ability to simplify auditing with artifacts. But most importantly, you are building a corporate culture around innovation and keeping motivation levels high. Typically, you'll see DevOps associated with the term CI/CD, continuous integration, continuous deployment, or using the agile methodology. For those of you who are not familiar with DevOps, that's okay. Let me quickly explain what it is. Basically, this is infrastructure as code where we automate all stages of building, staging, testing, and deploying code. And in some cases, we automate configuration changes. Now, let me ask y'all this. Raise your hand if you love automation in your environment, if you don't have it already. Yeah, I see those hands going up. Exactly. Here at CMG, we totally love automation, so we would be raising our hands too. Automation, in my opinion, is really neat. Plus, once you start integrating security into the pipeline, it's mind-blowing. So what is DevSecOps? Well, I'm glad you asked. As I just briefly discussed, DevOps is infrastructure as code, where we combine software development and IT operations. The focus is often on speed, quality, and rapid delivery, not security. Security is usually an afterthought that requires more work for everyone, the developers included, and it impacts the overall total cost of ownership. So how do we integrate security into the CI/CD pipeline? We start off by shifting security to the left. And by doing so, we reduce time and cost. DevSecOps is an augmentation of DevOps to allow for security practices to be integrated into the DevOps approach. Simply put, we are adding and automating security controls and testing to the DevOps process. Now, since this is a crash course, we wanted to present and demonstrate techniques that will allow you actually to answer this question. Should we buy or build our tools? There are pros and cons to both, and throughout this presentation, we will address how to do both for the basic tenets and point out the pros versus the cons. This is going to include secrets, SAST, dependencies, container scanning, and dynamic application testing. Implementing tools to address these security concerns in your DevOps pipeline will allow you to get the quickest value. Let's kick it up a notch and talk more about security, starting with secrets. Secrets are credentials that are sometimes accidentally or mistakenly stored in software packages or repositories. Is right, and that is not good. These credentials are often the target of malicious actors or script kiddies when trying to sneak into your organization. Some examples of secrets include private keys and stored credentials in JSON, XML, or CSV formats. These credentials could even contain the JSON web tokens, API keys, or even the good old username and password combo. Secrets are also sometimes inadvertently stored in the actual code as comments or database setup routines. Implementing tools to scan for secrets is a quick and easy win for your DevOps team. The next quick win for introducing security into your pipeline will be to deploy tools and processes for static application security testing, also known as SAST. Throughout this webinar, you're going to hear a lot of acronyms, and I am sorry in advance because we all love those acronyms. You're going to hear different product names, tool references, and other foreign terminology. However, here are some important acronyms you should understand when discussing DevSecOps. Static application security testing, also known as SAST, is used to secure software by reviewing the source code of the software to identify sources of vulnerabilities. Although the process of statically analyzing the source code has existed as long as computers have, this technique spread to security in the late 90s and the first public discussion of SQL injection in 1998, when web applications integrated new technologies like JavaScript and Flash. Unlike dynamic application security testing tools for black box testing of application functionality, SAST tools focus on the code content of the application, white box testing. The SAST tool scans the source code of applications and its components to identify potential security vulnerabilities in the software and architecture. Static analysis tools can detect an estimated 50% of existing security vulnerabilities. In the software development lifecycle, SAST is performed early in the development process and at code level, and also when all pieces of code and components are put together in a consistent testing environment. SAST is also used for software quality assurance, even if the many resulting false positives impede its adoption by developers. If you are using a CI/CD pipeline to deploy code, there's a really good chance your code has dependencies on other software that may not have been written by your developers. Much of the open source code available on the internet has vulnerabilities at some point in their lifetime. Or in simple terms, you can't trust everything that comes from the internet. So scanning for dependencies allows you to map out your code dependencies and scan everything in the software bill of materials, another acronym for you, also referenced as SBOM. And we scan for the following: CVE, common vulnerabilities and exploits; CWE, common weakness enumeration; and many of the scans also leverage and present a CVSS, the Common Vulnerability Scoring System. This system is used by NIST and the National Vulnerability Database to help you understand the perceived risk for each vulnerability, including the maturity of the exploit in the wild. Dependency scanning tools are not all created equal. They often vary in capabilities, mainly by the languages in use in your code. Testing the tools will save you a lot of time trying to address false positives. Now, even though the image on the screen looks really cool, bear with me while I pull up a visual representation of the dependency map for the Python setup tools. With Python, there are often a lot of software dependencies, and this visual is going to show you how they're all connected. And I'm going to zoom in so you guys can see. This visual is just insane. How cool is that? In my opinion, the visual looks cool and it's pretty, but we can go ahead and move on. Okay. Sorry guys. Okay. The last part that we're going to show you in this crash course is going to be the dynamic application security testing and how to implement it into your pipeline. DAST, also known as Dynamic Application Security Testing Tool, is a program which communicates with the web application through the web front end in order to identify potential security vulnerabilities in the web application and architectural weakness, which performs a black box test. Unlike static application security testing tools, DAST tools do not have access to the source code and therefore detect vulnerabilities by actually performing attacks. And one thing I did notice, guys, I did skip over the container scanning, so I'm going to go back one and discuss this with you guys. Since most of your CI/CD pipeline will run in containers of some sort, you will need to ensure that your code is secure, and also your code is hosting infrastructure is secure as well. For container scanning, we're going to show you how to scan your Docker file and any requirements associated with the projects that run in the container or image. Since containers are so prevalent in DevOps, there are a lot of best practices, such as scanning before you push to your public or private repo. It is recommended that you build and maintain your own containers, or at least leverage a SaaS-based service that builds and maintains the containers for you. When using containers, it is recommended that you leverage or use signatures to verify containers. For example, the Docker Content Trust. You should track security issues associated with each project in your workflow management tool. For example, issue tracking in Git Lab, GitHub, or Jira. Naturally, you should also remediate these issues immediately to ensure the vulnerable containers are not propagated further into other projects. That would be awful. And lastly, always continue to monitor and report on your container infrastructure. As much fun as I have been having discussing all this content with you, I'm now going to turn it over to Anthony, and I do hope that the demo gods are with him.
Thanks, Jen. Well, since you brought up the demo gods, we might as well make an initial sacrifice. We're going to sacrifice a virtual chicken. All right, so get this off. And it will be a virtual chicken. No actual animals or humans were injured in this process. First thing I'm going to do is push that to my pipeline. And we'll have a look, see if the demo guys are with us. Okay, there's our chicken. Once it's all done, we'll get rid of them. Okay. See you later, chicken. All right, so the first thing I'm going to start off with is an explanation of the workflows, mainly because there's going to be a lot of code and syntax and command line arguments that I'm going to be passing around. So before we get into that, I want you to understand the workflow. It's not the same for everyone, but it's common that you start off with your ticketing system connected to some kind of workflow management system. That could be, Jira, Bitbucket, Git Lab, whatever you choose to use to track your workflow for developers. And as Jen mentioned, you have your DevOps, and then you're inserting security to the left in the middle. But at the beginning of the stage, you're typically dealing with an application pipeline or an infrastructure pipeline. Either way, you want to track your workflow. So workflow management it's common for them to maintain manage bugs, enhancements, releases, projects, patching, or even application deployment. It's relative to your role and function, which we'll talk about in the next couple slides, which is more of a RACI matrix, so responsibilities and things like that. So from a developer perspective, they're fixing bugs, creating enhancements, building releases, focusing on code quality and code security remediation. And then on the security side, as we mentioned, some of the basic tenets, this is by far not a complete list, but it's enough of a list to consume a crash course, at least for an hour. So we talk about secrets, dependencies, vulnerabilities, static analysis, dynamic analysis, infrastructure security, compliance, and we will not be covering threat modeling, but you can get the idea of where that security pipeline will grow over time. So as a Kickstarter or as a crash course, you would want to focus on the quick wins. And then from an operations perspective, they're typically focused on building the app, testing the app, deploying, monitoring, maintaining, and keeping an eye on the infrastructure and maintaining that as well. All of that is typically controlled through source code management. Whether you maintain an application pipeline separately from your infrastructure pipeline is your decision. It's typically a best practice. However, if you're working with security, you want to be targeting the application for tooling. On the workflow management side, the responsibilities are use cases, requirements, creating the work items. So your PMO or your Scrum Master or your line of business or business owner would be creating those work items, or in a lot of cases, audit or security would also be creating those work items. They determine timelines, deliverables, assignments, risk management, and then auditing and reporting back to senior management. The developers focus on app architecture, coding, unit testing, some of the things we talked about before, and updating those work items and the source code. And then the security team focuses mainly on that infrastructure security, code security, vulnerabilities, dependencies, secrets, and updating their own work items. And then operations handles the provisioning, the deployment, the monitoring, maintaining, automation, integration, and additional work item updates. So what we're going to build first, as Jen mentioned, we'll talk about build versus buy. Build is going to take longer, so I'm going to show you that first. We're going to build a pipeline that looks similar to this, and then I'll walk through the step-by-step on how we're going to get there. We're going to have a security analysis phase, so to speak, a dynamic application security testing phase, because that occurs at a different level in the build pipeline. And then naturally a deployment. This has the infrastructure and the application pipelines combined for the sake of demonstration. So in that security analysis, we'll do container scanning, dependencies, secrets, linting or static application testing. We'll go through additional components as well and different tools for testing. And let's talk about the infrastructure. In this environment, it's important to understand the infrastructure because I don't want to assume that you know everything there is to know about DevOps, development, or security. So understanding the infrastructure is important. And I'll go through this very quickly. In my environment, I'm using VMware Workstation with a Ubuntu image with Docker installed. So I have VMware as my host on my Windows platform with a Ubuntu virtual machine. And inside that virtual machine, I'm running Docker so that I can host and build my container images. And I'm storing all my source code in Git Lab. I'm also running my pipeline from Git Lab. Pipeline syntax. So now we're going to start getting into the weeds a little bit. You're going to see this terminology or these keywords pretty often. I'm not going to review every line of every job, mainly because it would be extremely repetitive and incredibly boring. At the top of the page, you see a link. I posted it in the chat as well. If you want to follow along, because if your eyesight is like mine, where you spend most of the morning playing the game of where's my glasses, you're gonna want to follow along with those snippets. The local install for the development environment is available, as well as each of the jobs. In each of those jobs, you'll see a stage, variables, a job name, and then the stage that the job name occurs, and then the script, which is actually the command line argument that's being run either in the container or on the runner, which is effectively in most cases a container. And then artifacts. So you'll have artifacts with environment variables and paths. In those containers, you're going to produce output. So for example, if you scan for secrets, you're going to get output. That output needs to be available for review to send into your issue management or your remediation plan, or even just to communicate risk to your management and development teams. And then you'll see keywords like when. When is always. You'll also see things like allowed to fail, true or false. As a best practice with security pipelines or DevSecOps pipelines, you want to allow the job to continue, so failure is an option. Instead of blocking the build, if you're inserting your security into the application pipeline, you don't want the build to stop necessarily. You just want to identify the risks. If it becomes a critical or something that is intolerable from a risk perspective for you, you can stop the build naturally. But you can do that through keywords and controlling the pipeline. The snippets, if you follow the link, you'll see that all there is a README and a YAML file. That YAML file has a D before the first period. If you actually wanted to run a pipeline, you'd need to remove that D in the Git Lab environment. I have it there so the pipeline does not run. And all of the snippets are on the left-hand side if you click the snippets button, and you'll see that we have the local install for command line, as well as the pipeline script syntax. So the pipeline that we're going to build is relatively simple. In this scenario, I am the developer, the security operations, and the DevOps team. Typically, that would be compartmentalized, but for the sake of sanity and demonstration, I will do all three. What we have is my PyCharm environment. I spent a lot of time working with Python. We'll be deploying the CMG machine learning applied cybersecurity application, which I'll show you in a second. And then we'll be pushing that to the Git Lab source code management environment, which will trigger a pipeline. That pipeline is a YAML file. And it is currently, or we will build it in a way that we're deploying a dev, test, and production environment. So that's a typical application deployment. This has nothing to do with security. So let's get started with that. We'll get that going. So this is where you would start. Maybe you already have an application pipeline, but either way, you're going to be needing to test your security tools or run your security tools against an environment. Since we've already sacrificed that chicken, we can get rid of this. And we'll go with the base configuration. Naturally, I'm copy pasting this because I don't want you to, one, have to listen to me typing, or two, watch me hit backspace 7,000 times. What I just did was created multiple stages and multiple jobs. In order for this to work, I have to define stages. And in this case, I only have one stage, which is deploy. In my environment, in my GitLab pipeline, I have environment variables defined, and they identify my dev instance, my test instance, and my production instance. These are all applications hosted in Heroku. And naturally, if I'm pushing there, I'm using my API key. I'm using DPL to deploy that application. So the reason we do that, one, it's free, and two, it's very easy. So let's take a look at what that app looks like first. The app itself is running locally here. I built a machine learning model. If you're interested, it's support vector classification using natural language processing. But effectively, I took ASA syslog messages. I trained a model, and this application is just the front end to that saved model. And the goal of it is to identify ASA syslog messages and determine, based on the enterprise security team's classification, as to whether it's important or not. When that string is pasted in here by whoever is reviewing those logs, whether in your SOC or whatever the case may be, they can determine what the level is. This is just a proof of concept application for a larger project, but it just demonstrates how the model is able to accurately predict, based on classifications determined by the security team, whether something should happen. You know, what you would really do is put an API in front of this and force your syslog messages through that API. So it's pretty simple, pretty straightforward, and that's what we're going to use. So you can see it determined DEFCON level 2. And here we might have a license expired. This is a DEFCON level 1. And you can see that it accurately predicted it without conditional logic. Okay, enough of that. Now that we have our stages set up, I'm going to push this to through the pipeline. And we'll just say base builds, commit that, push it. And let's go see what our pipeline just did. Now we know the chicken is gone. Bye, chicken. It triggered an update, and that update is basically running that pipeline. So it's going to deploy development, production, and test. You'll see that I have production set as a manual trigger. And if you want to see what's going on in that pipeline, it's loading this Docker image, which is the Ruby 2.5 image. And then from there, it'll go through a series of steps where it'll build and deploy the application out to Heroku. And it could be AWS, it could be Google Cloud, Azure. It really doesn't matter. In that case, you might use a different tool. I just prefer Git Lab. So we'll let that keep running, and I won't bore you with that. That's the first stage. So we have a development environment. We added information to the pipeline. I showed you the application, which is a CMG machine learning, pushed it to source code, triggered the pipeline, and now it is building these environments. The next step that we're going to take is to add security to this pipeline. And the first thing we're going to do for the quickest and easiest win is implement secrets. And for secrets, I'm using a tool called Git Leak, which is free and open source. And then we're going to add, well, let's do that first, and then we'll talk about what we're going to add next. So we've built the pipeline. Now we're adding secrets. So let's do that. So from a secrets perspective, we're probably going to need another stage. In this case, we're going to call this security analysis. And now we'll need to add the secrets pipeline. And I will show you how you build these components in a few minutes. Okay. And we'll add this before. What I've done here is basically created some variables. One variable is my Git Lab token. I want to give Git Leaks the ability to access this repository. And it's going to produce an output in CSV format that tells me all the secrets that are stored in my repository all the way back to the last 100 commits. And we'll go through the command line in a little more detail later. But as you notice, there's also artifacts and reports that will be generated. So we'll push that, and you can see the next phase will be to add secrets. This is about how easy it is after you've determined all your command line. And we can hope that our YAML file has passed the linting process. And let's go take a look at the pipeline. It should have triggered a new pipeline. And you can see that our base build has completed. And now our new pipeline is started. And that new pipeline is running. And it's running our Git Leaks process as well. So we'll let that run, and then we'll go back and take a look at the output. And for the sake of sanity, we will move this up because this should be occurring before, not after. That was a typo. Okay, so the security analysis phase on the next run will be up there. The next phase that we're going to add is linting and dependencies. Those, I'm going to paste those in together. And for linting, I'm using a tool called Mega Linter. This is going to take a long time to run, which is why I put it in the front. And it's a quick and easy win, but a Mega Linter effectively is a tool that uses multiple languages and some of the best of breed linting tools that are out there, and produces an enormous amount of output based on code quality as well as code security, with recommendations and the ability to actually correct that code automatically if you wanted to. I wouldn't recommend that on production code, but if you wanted to generate snippets for the developers on how to fix it, this will do that as well. And then from a dependencies perspective, we're going to run the Sneak CLI. This is a pretty common tool. It's free, and there is a paid version, but the free version does a pretty good job of, one, scanning your environment for dependencies and producing a pretty output report for management. Again, everything I'm showing you is free, and that's because this is the build section, right? This is how you would go about building it. I'm demonstrating doing it, and I'm going to show you how to build these configs. So we'll go back to the environment and add those first two. I'm going to add my mega linter job. And I'll also show you how this mega linter configuration was built, but you can see that I'm using someone else's Docker container, and everything else was generated by the tool. So we'll do dependency scanning as well. I wouldn't focus too much on the syntax right now because we're going to go through and build this config, and I'll show you how we went about doing this. Here, I'm going to use my own tools and my own Docker container that I built. And in there, I'm going to install the Sneak tools and supporting infrastructure, which in this case is NPM. I'm going to install the Python requirements for my application. I'm going to authenticate to Sneak, and then I'm going to run a test against those requirements using the Python command. Allow missing because I do not have a pip file. And then I'm going to produce a report called Sneak Depscan results.html. And the reason I need that is because the default output is JSON. We'll look at JSON and how to deal with that in a few minutes. But I've added dependency scanning to the job, the dependency scanning, and the mega linter. Now, the mega linter is effectively a static application security tool, but also a code quality tool. So I'm getting the benefit of both. We're going to commit that. And push it. That again seems a little bit repetitive, but that will also trigger another pipeline. The previous pipeline is still running. It says that it passed, but you'll notice that Git Leaks failed. And you'll also notice that while that's running, it continued to deploy the application, and the other pipeline was triggered, and I moved security analysis. So now you see 3 jobs occurring before the deployment of the application. So I'm scanning for dependencies, credentials, and linting or SAST. If we go back to the pipeline that I showed you before that says that it passed but has an exclamation point, that's because Git Leaks found something. And I know it found something because I staged a whole bunch of fake credentials. One is fake JSON credentials, as well as fake private keys, which you can see here. I did that on purpose because I'm trying to make sure that my tool is actually working and producing the output. I also configured it to generate a CSV report. And the CSV report that I generated was based on redirecting output to that file. And I'll show you the command line for that as well. So we'll let the other pipeline run. More than likely, it's already passed the Git Leaks part. And now it's running dependency scanning and the mega linter. And we'll go back and look at the output from those as we add pieces to our config. So coming back, we added static application security testing, which the mega linter will use multiples. And then we're going to add a container scan followed by dynamic application security testing. The container scan will be based on the Sneak CLI container test as opposed to the Sneak CLI dependencies test, which will identify vulnerabilities in the application. This will identify vulnerabilities in the configuration and dependencies for the container. This will all be based on my Docker file, which we'll see in a minute. And then the dynamic application security testing uses OWASP ZAP headless so that it can scan my CMG application. In this case, I'm only scanning the dev environment, looking for vulnerabilities. So we'll add those two to the pipeline and we'll continue. I have multiple container scanning solutions that I'm going to demonstrate. This is just one. So we got dependency scanning, put container scanning closer to here. And we'll take a look at that very quickly. What I'm doing is I'm using my own image. I built another Docker container called CMG Applied ML, which is effectively a Docker container that I set up for machine learning apps. It also has some security tools installed. And we know it has Node Package Manager, much like the other tools, as well as the Sneak to HTML tool, which allows me to take that JSON format and make it pretty, which you'll see in a moment. The command line is different here because I'm actually doing the Sneak container test as opposed to just Sneak test. So Sneak container test says test this container, which I could use as an environment variable, but I wanted you to see specifically so you weren't getting confused by the $signs. This is the image that I'm going to scan. And I have a Docker file in my repository that is right here that I'm going to use to direct towards that as well. There are known bad configuration changes in here, so I want to point that out up front. I did that to stage it so that you could see something in the output. That Docker file and that image will be scanned. The output will be in JSON, and I'll convert that JSON to HTML using this configuration here. And all I'm doing is piping the output to the other tool, and everything else looks pretty much the same. I'm allowing failure and I'm building artifacts. So that is container scanning. And then the last one we're going to add is the dynamic application scanning. Now you'll notice the one thing different here is this has a DAST stage. As I showed you in the image of the pipeline, we want to keep this separate. So we're going to need to add another stage, and we'll do that just before deployment. So the dynamic application security testing will occur with this job during this stage. From an image perspective, I'm using an image actually produced and maintained by the OWASP Foundation. I'm targeting my own website in the development environment. And then I'm running the basic commands that I need to leverage what's in that Docker container. And I'm running a zap baseline against my website, producing a JSON output. Here's the environment variable for my website, which is that $sign. And I need to pass a true argument to it. And then I want it to produce a report. And as I mentioned before, these are all the same. So let's commit and push that. Okay, I should be off to the races. So there's the whole pipeline. We've taken a basic application pipeline, we've deployed the app to 3 different environments, and now we've implemented all the security tools, which we built ourselves. I will show you later an even easier way to do this. So let's go take a look at the pipeline. It may take a little bit of time to run, and this one should be finished. Nope, still going. So the dependency scan ran, it failed because it actually found some artifacts and it produced a report. And that report is the Sneak Dep Scan results HTML. When I click on that, it'll tell me the reasons why my code failed, or at least on that dependencies check, and give me some output that I can use to create issues for tracking later. And then if we look back at the pipeline, the one that recently ran or is still running, we also have the Git Leaks, which has the same results as the one before, because this is what we passed in. but you can see here that it has the actual passwords and everything that it found. Normally you can hide this. I produced it so that you could witness the findings. And our other pipeline is off to the races. So we'll let those run. It's going to take a little bit of time, but you can see now we have container scanning, dependency scanning, secrets, which is Git Leaks, and a mega linter, which is doing static application security testing on all the languages. So it's scanning my CSS files, my Docker file, my Python files, as well as HTML and any JavaScript that I have, and even my markdown for my README. Then when that's finished, it'll run through the dynamic application security testing and give us an opportunity to push dev and test and manually trigger production. So we're going to let that run for a little while, and we'll come back to the slides. So how did we get to this point? How did I get all these commands? Some of them were a lot of Google foo, and more than anything, it was a whole lot of trial and error. So with that being said, I wanted to give you a foundational approach. So first, understanding your application, know what the code base is, know what languages are being used. And if you don't know, you use a tool like Megalinter or some of the other paid tools that are out there. It will identify your code either through machine learning or just through file type extensions. Keep in mind that malicious actors are not going to follow the standard baseline of file naming conventions. And you may have something that gets converted or renamed and used maliciously. So everything should be scanned with a lot of due diligence, but your SAST-based tools will typically identify those as well. So understanding the code base is important. You don't have to be a programmer to know what language is being used by your application. And in my case, I'm using Python, so it's good to understand Python and understanding the Docker requirements, like what needs to be in that build. After that, you'll want to set your security scope. What do you plan on doing to this application from a security perspective? What do you need to do? Well, there's a long list of things you could and should do. I'm giving you the short list of things that you can do relatively quickly with very little cost other than your time. And even if you buy tools, they're relatively inexpensive as well. So you can get a lot of bang for your buck and a lot of situational awareness about the security posture of your application, which may have been foreign to you before this. Then you have to select the tools. There are tons of tools out there. They all have crazy names. So if you don't like acronyms or crazy names, DevOps, DevSecOps is probably not the best place for you, but you'll develop a vocabulary of completely or seemingly useless words to everyone else except for people who do this for a living. So in my case, I chose Git Leaks, Megalinter, Gripe, and the Sneak CLI, as well as Trivi and the OWASP Zap tool. There are other tools out there. I added Gripe and Trivi because that's actually what Git Lab has selected as their tools of choice for container scanning. And after testing them on my own, I think they're pretty good choices. There's some others out there, but like I said, these are really good. Then you have to build your development environment. As I showed you about my infrastructure, I'm using a Ubuntu VM on my workstation where I have Docker installed and all the necessary tools that I need to support that environment. And then last but not least, on your local machine, so that you're not triggering a build in your pipeline every time you modify one line of code in your YAML file or your pipeline file, you want to test the command line and test the outputs. So you understand what needs to be run in the script process of your pipeline and what the expected output is and the format. I can tell you that when you take the build approach, the biggest challenge will be trial and error of testing your tools, as well as even more effort in dealing with the output. So if you're not familiar with JSON or XML or CSV or TSV files or even text files and processing them properly, you're going to want to look for something that is more efficient. And there are a lot of great tools out there that are relatively inexpensive that you do have to pay for that will do a lot of that work for you. This is the free version. So this is the Road Warrior hard-headed approach, and it does work. It's just very time consuming. So if you like geeking out, this is the way to go. So after you have your environment built and you've determined the proper command line and the proper outputs and formatting for those outputs, you're going to need to build an image to host your tools. And that image is effectively a microscopic version of an operating system. Imagine that it's kind of like a mini operating system that will run in the pipeline and host your tools and only have installed what's absolutely needed. So there are a number of different images that you can use. Imagine this is your jump box out in the cloud where you're going to run your security tools. So you create a file that will allow you to do that. From there, you build that image from that file as input. Then you push it out to a registry, and then you build your pipeline and call that container. When that container runs, it's going to be called by the pipeline, and it's going to run the command line or script commands that you've configured and give you the output that you need. And it'll save it in the form of artifacts. I'm a Ubuntu Python guy, so my nano command is really just here. You can use any text editor, you can use Sublime to build it, or you can use your IDE to build your Docker file. A lot of them will give you intelligent responses to help you with syntax. From there, you're going to need to actually build the image and then push it to your registry. So enough talking about it. Let's take a look at it. So before we get there, let's just talk about the pros and cons of building. So when you're building, it's going to give you a lower cost, but a higher time cost. You're going to spend a lot of time working with these tools, and in about a minute and a half, you're going to see what I mean. And I'm not trying to scare you. I'm just trying to prepare you. You're going to need to build and maintain your own containers or use others, which is a best practice. Select the best tools, understand the options and container dependencies, expect false positives and be able to respond to that and create exclusions so that false positives are negated in future reports. Then go through the reporting process, interpreting the output and tracking it with your remediation system. So let's take a look at how you build this start to finish. I will not be pushing my Docker container because that would take longer than this webinar is scheduled for, and I've already done it. So here's my environment where I've pulled my project down and I've cloned it so that as I add components to the environment, they will be pushed up. But most of the tools that I'm running, I'm not going to run through my integrated development environment. I'm going to run them through a terminal. That's just my weapon of choice. You can do it from the command line in your Windows environment, whatever you like. But I try to operate in an environment that mirrors what my container is going to look like. So one of the first things we'll do is look at the tools, run the commands, and I'll show you how some of these tools work. Let's start here. So the first thing that we did was we introduced Git Leaks. So what I did was install Git Leaks in my environment. I moved to my repository. So you can see that my app is called CMG Applied Machine Learning. And before that, I'll show you that I'm actually in the repository. Git is initialized. So I basically, anything I change here will get added. It's typically not a best practice to run your tools in a initialized state because all of your output might get pushed up. And now not only is your application deployed, all of your vulnerabilities are public. So be careful with that. But for the sake of demonstration, I'm going to run this command here. So this command is effectively, and I'll zoom in a little bit if you can't see that. I'm running the Git Leaks command. I did a Git Leaks install in the Snippets section of that page that I shared with you earlier. The commands to install Git Leaks are available. Git Leaks -v is verbose, -p is the path. I'm using the period as the current working directory. I'm expecting an output of Git Leaks report.csv, and the -f is the format. I could use JSON or table, something like that. And then my configuration is pointing to a file called .gitleaks.toml. And I want to scan for a depth of the last 100 commits for my repository. What that means is if someone posted secrets in a previous commit to the repository and then deleted them, that doesn't mean that they're gone. It just means that they're not currently in the pipeline, but they were at some point in the repository. So I want to dig a little deeper into the depth of all the commits to see if they ever were out there at any time. When I run this command, it's going to give me a JSON output and identify every one of the secrets that are there for every commit that has ever occurred. The typical output being JSON is not very user-friendly or easy to read unless you're familiar with JSON or using the JSON query tools. So what I did was I put it in CSV format. So if we look here, you'll see, there's my file. I can open it and you can see it is CSV, but you can see that it tells me all the things that I need about this environment. Reading it at the command line kind of sloppy. So what we'll do here is we'll come down and look at that file. In an application that was designed for reviewing these a little more effectively. So what it tells me is this application that didn't work too well, did it? If you look here, it'll tell me we're going to do comma separated, not tab separated. It'll tell me every commit. It'll tell me the offender, and it'll tell me the file. It'll tell me which rule in my config found it. It'll give me tags to tell me what type of credentials it was, which commit and where it occurred, who made the change, their email address, the file that they modified, and the date and time, which is all pretty much what you would need from an audit perspective. And in a lot of cases, it'll tell you exactly what changed in that commit so that you can identify where the offensive credentials are stored. So that's secrets. If you look at the pipeline, the way that I added those commands was pretty much the same as what we just ran. And I'll pull back to that in a second, but you can see I'm running Git Leaks from a repository that is very similar in command to what we did here. So in the editor, when I ran Git Leaks, I specified a token, but if you come down to the command line, this is pretty much exactly what we just ran. And that's how I built that part of the configuration. I identified the job, the stage, allow it to fail, and the image. This is an image that is pre-built by the developer. So it made sense to use that. And that's how we got to that point. So the next one that we would do is take a look at the container scan. So Sneak CLI is a tool that's pretty widely used for scanning for containers or scanning for dependencies. So here, in order to do that, I had to create an API token, an access token with Sneak so that I could authenticate. So when I run this, it's going to try to authenticate to Sneak and tell me it either did or did not. Here, it prompts me to authenticate so they can generate a token. The reason that it prompted me here is because I didn't have that environment variable set. So now if I try to authenticate, we should be good to go. So your account has been authenticated. Sneak is ready to be used. Great. I've already installed Sneak, the snippets out there if you want to follow along. And then I went through the process of building and testing the command by looking at the help. So if you look at the Sneak CLI, it'll give you a number of options to tell you what you can or could or should do. I'm not going to review every one of those. I'm just going to show you the net result. Since I know I want to scan a container, I use Sneak container test, and then I have to specify the container to scan. In my pipeline, this will be an environment variable. Then I want to direct it to my Docker file, which is part of my repository. I showed that to you before. I'll show it to you again. I want my output to be in JSON format, and I want to pipe that to the Sneak to HTML converter, and the output will then be HTML. These are the commands that I run in my container, and I'm testing them locally to make sure that they work. This will produce a report, and you'll notice that it's analyzing the container dependencies. It's going out and pulling down that Docker file, and it's going to produce a report that will give me something useful. We'll look at that in a second. And while we're waiting, you can hear I don't know if you can hear my computer running, but it's doing quite a bit. We'll also use the Sneak tool to test the requirements of my application. So here I'm doing Sneak test. You'll notice that the container keyword is not in the arguments. I'm using a debug mode, and I'm looking for output in JSON format. I want to target this particular file, which is my test requirements.txt file in my repository. I'm going to be running a Python 3 application, so I want to use the command Python 3. This took a little bit of research because there's not as much documentation out there as you would think for that. Then I'm going to allow missing because I'm not using a pip file. And I'm going to, again, pipe that output to an HTML response. So this should run very quickly. So it found some things, and now it's writing it to that text file. And while we're waiting for this container to scan, so the container scan finished and the dependency scan finished. They're in my repository, so I should be able to come down here and look at my container results. And you can see that there are 39 known vulnerabilities, 282 vulnerable dependency paths. I don't know if you remember the wormhole diagram that Jen showed, but that was pretty slick. It tells me the Docker file, Docker container, and it starts to tell me all the things that are wrong with my environment as per the National Vulnerability Database hosted by NIST. So it'll tell me everything. The problem is I got a lot of stuff here. Some of it might be a false positive, but more than likely I have a lot of work to do. So after running this report, I get the idea that, okay, my container that I just built needs a lot more work than I thought it did. I knew that it did. I did that on purpose. Then my requirements.txt says that there are, that can't be right before. Sneak container, sneak results. No known vulnerabilities. I find that hard to believe. So we're going to run that again against the different requirements.txt. It's always a good idea to make sure that your application is giving you the proper output and proper format. And if it tells you there's no vulnerabilities, chances are it's lying to you. There we go. So I was using that test requirements.txt, which is pinned and may not have vulnerabilities. When you see that I pointed it to the requirements.txt file for my Python application in production, you see that there are a number of vulnerabilities. Many of them are high severity, and you see there's 23 the vulnerable dependency paths and 26 dependencies. So again, I have work to do, but this report tells me when it was run, and I can use that to go and create an issues list or a backlog for my development team. So that's that command. Let's clear the output on those two. And let's look at a couple other tools. So another tool that I have is a tool called Trivi. Trivi has configuration, file system, and container scanning. This tool is also going to be added to the pipeline, and there are snippets out there for it. If you want to see what Trivi does, you can run Trivi-H after you install it. But it's a simple vulnerability scanner for your containers. And what I'm going to do is just look at the configuration and clear this. Just using another tool to find out which one is going to work best for me. So when I run Trivi config, it says this Docker file has these issues. Well, that's great. But if that runs in my pipeline, it's not going to do much for me if it's just sitting there on the pipeline screen. So I'm going to pipe that to just a text file so I have an artifact, and maybe I'll call it Trivi cfg out.txt. Okay, we know that's going to run. So if I cat it or try to read it, we see that the output is there. That looks good. So I know that's going to be a good one for my pipeline and my artifacts. The next is the Trivi image command. So you saw I ran Trivi-H, and there are different options. You can do file system, repository, configuration, plugins, and image. I'm going to do the image scan, which is going to pull down that Docker container and scan that. So you'll notice here I'm using an environment variable that may or may not actually exist. So I'm going to test it and realize that my image is missing something. So if I print env pipe, I can see that I do not have an environment variable listed. So in your pipeline, you're going to use environment variables, and on your development machine, you're going to want to set them as well. So what I should have done before I ran that is set my environment variables. So let's quickly create that. Okay, that's a good image. And we'll run that again. Actually, before we do that, now we'll see that we have an environment variable that is called container to scan. Clear that. And let's run the Trivi image again. So it's pulling down a database. It's pulling down an image and running a vulnerability scan. Now I ran this before, so the image was already there, but you can see there's a lot more output on the vulnerabilities, and it's formatted in a readable format. And this is the table format, but there's also a JSON output. So what I'm going to do is just pipe it to a text file for now, but I could also pipe it to JSON, to a JSON file. So let's do that again. And just for now, just to get a quick win, we'll say Trivi ctnr out.txt cat Trivi. All right. We know that that file is there. That's going to be a good command for our pipeline. And if we like the output better or the speed better, we use that one instead of the sneak tool. Some other tools that you could take a look at is a tool called Gripe. Gripe is created by the Anchor team. That's a pretty commonly used tool. They have an open source and free version, but they also have paid versions. So the paid versions do have a lot of value if you don't want to go through the process of building your own configurations. But before you can run the Gripe command, you have to create the software bill of materials. You heard Jen reference the SBOM. SBOM is your software bill of materials. So what you're going to do is run the command, which is the sift command, which is another tool that had to be installed also from Anchor in their documentation. I run sift against that container that I selected before. I want the output in JSON format, and I want that to write to a JSON file called image sbom.json. So that's going to run. It's going to load the image. It's going to take a little bit of time because I'm pulling it down from Docker. I actually had this file local, but I may have deleted it. So it's going to create that bill of materials. Once it's done creating that bill of materials, I'm going to run another command against it that will load that bill of materials, and that's the gripe command. So it's catalog, it loaded the image, it's parsing the image, and it produced that output file. Now, if I take that output file, as input, so I have my gripe application. I could have piped them. My gripe application using the SBOM argument and points it to that SBOM file. And the output from that scan, I want it to go to the gripe results vulns.txt. And that's basically scan this image and write the vulnerabilities to a text file. I'll take that off just so we can see it without the text file. It produces a readable table, which tells me which components, which versions, and which CVEs are associated. And it also gives me the medium, high, low. The problem is this output is just to the screen. I could write it to a text file, or I could write it to some other format. So let's change that and write that to a JSON file. And we're going to write it to JSON because that is the only other output format that I could find available for that file or for that application. I'm going to take JSON and then I'm going to use another tool to take that output and convert it into a tabular format and write that to a file. And this is what I meant by building. Building, you're going to need to have some command line expertise in the development environment and the ability to manipulate that output. So the JSON file is going to come down, it's going to build this file, write it out. You're going to see what JSON looks like. And then you're going to realize that this is a very difficult thing to hand to management. So I'm going to show you very quickly how to use a tool called the JSON query tool, which is also installed. And what I'm going to do is read that JSON file. I'm going to pipe that output to the JSON query tool in raw format. From there, I'm going to capture the ID, the severity, the description, and the CVSS base. Now, I've actually removed the description because it doesn't look very visually appealing on the screen. And then I'm going to write that or pipe that to a CSV for later use. So I'm going to run this first. When I run that, it's going to create that CSV file. So if I cat gripe out short, you can see now that I took JSON and created this, what I would call relatively easy to read output format. But if I were to run the same command and get rid of all of this and just read that JSON, you'll see why I took that data and said, you know what, I can even leave the pipe raw in there. JQ-R. This is what JSON looks like. Imagine sending that to your manager and saying, hey, guess what? We got a problem. You're going to say, yeah, we got a really big problem. I can't read that. So you want to look at the output produced by your tools so that you format it properly and realize that there are tools out there that you can use. I don't expect you to become an expert in JSON query languages right away, but just know that it's possible. And you can take this, even though this is a pretty version of JSON, you can turn it into something more usable so that you can share that with management and say, these are the vulnerabilities that we found. If you wanted to make it a little more robust and actually create the full description, you can add other fields from that JSON here. So I'm basically saying in that JSON, get.vulnerability severity, the CVSS score, and the ID. That's actually the wrong command. Okay, here we go. Here, I'm going to run this so that I get the command, the vulnerability description, and the base score. So this is going to look a little less attractive on the screen, but it will be great for data analysis later. You can see that I have similar content, but that data now also has a description, which not beautiful, but it does give you an opportunity to pull data out of that JSON. I'm going to continue to keep moving here. We've gone through quite a few tools. The last one I would go through is the Mega Linter tool. Now, you don't want to run this in a demo because it's going to take a really long time, but I'm going to kick it off just to show you. So Mega Linter is a tool that has multiple linting tools in it, and I'm specifying the path. And in this path, I've hard coded my machine learning applications path. And what I'm telling this application to do is scan everything you find in there and tell me what's wrong with it from a code quality or a code security perspective, and dump that into a series of output files or logs. I've already run this command and it takes quite a bit. You can see when it's all finished, it'll tell me a full summary of what occurred in my environment, and it'll create a log file for every one of these things that it made. So there's a folder called report, linter logs, and one for every one of these. So this one, there were 33 files, 33 errors. This is how long it took in seconds. So it gives you quite a bit of information, and it will actually fix them if you want them or need them to. So this is highly configurable, but it gives you a full list of all the programming languages that it included. So it's even scanning my Git files, my Docker files using multiple linters, my Python using multiple linters. You can see here for Python, there's quite a few. So it used Bandit, Black, Flake 8, MyPy, PyLint. You get the idea. There's a lot. You got ESLint being used for Json, V8R. We have Hadolint and Docker file lint. So there's a lot of linting occurring, but I didn't have to configure all of these. All I had to do was grab that output. So when this ran, which took quite a bit of time, it produced a set of folders here. And every one of these logs tells me what that linter came back with. And you can see those are relatively large. And just to give you an idea what output looks like when you're building your own tools, let's take a look at this Docker file. So it linted my Docker file, which basically meant it inspected it for quality and security, and came up with all of these issues. There are literally, tens of files, and some of them are 41 megs in size. So Python Black went through and analyzed every line of my code and told me these are all the things that are wrong with it, these are all the things that are right with it, and gave me a complete list of all the things that I need to fix. And it says I would have reformatted this by doing, adding these and removing these. You get the general idea. With that being said, let's go back. So that's building, right? When you're building, a lot of time, low cost, but you have to do all of that work and produce the output. So as I built each one of those commands, I added it to the pipeline, which you saw over here as it ran. So I created my stages, I created my variables, and then I added every one of these jobs, which had a similar format, with the only exception being me proving that I could get the right output from this script syntax and output my reports here. So that's effectively what we have for all of those. Let's go look at that pipeline just to see what happened and what our output looks like. So as I mentioned, the linting took quite a bit of time to run. My container scan ran, it produced an output, it produced my report. And I knew the report would be produced because I tested it locally. I went through and ran my dependency scan, produced a report. There's my report. I'm not going to click on every one. You get the idea because you've seen them before. Got my Git leaks. So I looked for secrets. I found a bunch of secrets. There's my report. Artifacts are key from a security perspective because that's your proof that you found something. And then the Mega Linter ran and came back with an enormous amount of output. And that is where false positives start and developers start getting a little squeaky. But this is highly configurable. You can specify which linters run, whether it corrects code or not, and how sensitive it is to typos and standards. But one thing to keep in mind from a security perspective when you're dealing with developers, sloppy code leads to insecure code. So if you have a developer who's consistently failing quality checks, chances are they are your most likely candidate to introduce security issues by accident. So they're the ones you're going to want to talk to and maybe get some training for. But when we look at the output for this, there is a large amount of output. So in my linter logs, it tells me all of these things. So you don't need all of these. I did that for the sake of demonstration. And then the last part that ran in the pipeline was our dynamic application security testing. Oh, wrong pipeline. We'll go back to the last time that ran, so you don't have to wait for all that to finish. So again, these take a little bit of time to run, but what we did here was we ran, this one failed, the OWASP ZAP headless scan against the application. And you can see that it kicked off the script, ran through a number of scans, and told me whether or not those scans were successful or failed. And it also produced warnings that said, these are things that you want to check out. You can see that it clearly targeted my dev environment and gave me a 200 OK, which means it connected to the application. So it's warning against a live application. And then it successfully deployed development and test. Production failed because I did not, it timed out after I didn't click the manual forward. All right, so let's go back. So the other opportunity you have, besides for building, is buying. I highly recommend this if you're not a programmer. I highly recommend this if you're new to DevOps. And I highly recommend this even if you are experienced. Why? Because it saves you a ton of time and allows you to focus on your real job, which in this case is probably security or DevOps. You have a lot of control over what you can do, and there's a lot of integration. What I'm talking about in particular here is Git Lab. I use Git Lab Ultimate because it has the security pipelines built into it, and I can configure every variable that I need to, as well as having it as open source. So I don't have to wonder what's going on behind the scenes. I just know that Git Lab and their entire team of security experts and professionals are building and maintaining these tools. And as long as I trust that to a certain level, I can forego a lot of the work that I had to do, which allows me to innovate more and focus on things that I can't buy. So for $99 per user a month, and again, I'm not in sales, you can't buy this stuff from me. I'm just telling you that the amount of time that you'd have to put into it is well worth $99 a month. So I have Jira integrated with GitLab. I have the same pipeline. I have my PyCharm application, my CMG app, my source code management, and this is not GitLab free. This is the paid version. I have one pipeline. That pipeline is going to push an app to Heroku, and that app will be my CMG machine learning app. I'm going to show you how quickly and easily we can add secrets, as well as having control and custom rule sets. And that secrets actually uses Git Leaks as well. I just showed you the manual way to do it. If you have the the Git Lab subscription, you don't have to do any of that. They also have a template for static application security testing. It automatically determines which scanners are best for your platform based on file types. So similar to the Mega Linter, this will go in and say, I see Python, I see JavaScript, I see CSS and HTML. So I'm going to run these three, which is Bandit, SemGrep, and ESLint. You don't have to take notes on that. There's a lot of tools out there. Then it's going to scan for dependencies using the Gymnasium model. Then it's going to use container scan, which in this case is Trivi or Gripe. And it's going to kick off the OWASP ZAP. So everything that I did manually through pain and suffering and scripting and testing, they've already done all that work for me. So what I just showed you will look like a pipeline like this. And I'm going to show you how that works in a second. And that'll be my last demo. So that is a separate pipeline. Over here, you'll see my CMG applied full security. What I have is a pipeline that incorporates their templates. All of this was added to the pipeline. So I have a test, production, and dynamic application security testing. If I look at the editor, detect your speaker. Sorry, I had a little audio problem there. I have 3 stages, or 4: test, production. This post is not actually used. And then I have a DAST, or dynamic application security testing. If you look at my config here versus the one that I showed you before, the one that I had to create manually, or the hard way I like to call it, pales in comparison to this one. This entire config, from my perspective, is 27 lines, and that includes spacing. So I created my stages. And then from there, I created variables. And these variables are how I control the templates that are provided by Git Lab. I created my basic application pipeline, which deploys my app to production. But to get security introduced, I used this include statement. And the include statement allowed me to call templates provided by Git Lab. So they have one for dependency scanning, static application, secret detection, dynamic application security testing, and container scanning. All that I had to do to get this up and running was specify my website, and you don't need this debug, and specify my Docker image. Once I do that, it just runs the pipeline every time for me, every time there's a code change, and gives me an output that says, you succeeded or failed, right? So if I look over here, it ran all these linting tools, and I don't have any output over here. You saw how clunky the output I was producing looked, right? And chances are, unless you're some kind of front-end developer and you're more of a DevOps and a security person, you're not going to be a formatting whiz kid when it comes to web apps. So the beauty of this platform for 99 bucks a month, in my opinion, is this. Every scanner produced reports and output. So if I just want to look at secret detection, I can come over here and find all the secrets that were found in my environment, click on it and say, okay, there's a JSON, my CMG custom generic JWT detector, and I wrote this through regex, found credentials in my repository. So if I click on it, I could say, yep, that is definitely an issue, right? So from here, I have it integrated with Jira. So when I click on the create an issue in Jira button, that will send it directly to Jira with all the details and the links to everything, including the artifacts. I can put myself down as the reporter, and now I can very easily follow up or assign this to someone else. In this case, I'm just going to assign it to myself. But now that issue is tracked and in the pipeline. It is now in the backlog as an issue to be investigated from a security perspective. I didn't have to format anything. All I did was click buttons and review the output. The same level of reporting is there for every scanner. I didn't have to create text files, CSV files, JSON, XML, you name it. I didn't have to do anything. All that was done for me. So my container scanning, same results. I didn't have to maintain my tool set. All I had to do was configure it. So it'll tell me the exact output. I can turn that in and say, okay, this is a legitimate issue. I can set it to either detected, dismissed, confirmed, or resolved, or I can move it to Jira and have that assigned to someone for correction. Same drill, I would assign it to myself, so on and so forth. So you get the idea. My demo for paid for tools was much shorter for one reason. I didn't have to do all that work. I didn't have to format reports. I didn't have to test it. You're still going to have to test, but it's a whole lot less work. So we've already seen it. Let's discuss it quickly. So slightly higher cost, 100 bucks a month, but my containers are maintained. The tools are already selected. I have full control over the options and a well-documented command line interface. I have support for those tools. I've reduced the false positives through crowdsourced and subject matter expertise. I've integrated reporting. That's a big gold star for me. The best output format allows for immediate review and prioritization. You don't spend 3 days trying to get a pretty format to find out that your manager only wants to look at a pie chart. What I get here is a simple, easy report that I can deliver, add to Jira, and assign to someone directly. I have integrated issue remediation and tracking. I don't have to use Jira. I could use the built-in tools with Git Lab, and it gives me faster time to value. I can be up and running with a fully integrated security pipeline in probably a week, especially if you separate your infrastructure from your application pipeline. Resources for your consumption, as I showed you before, I'll show you again. There is a full set of snippets out here. If you go to the repository and look at the files, you'll just see a README that tells you go to the snippets. Here's the snippets. You have the installer, CLI installer, Linter, Gripe and Sift, Trivi, Git Leaks, CMG, DAST scanning. These are the ones that I had to create myself versus the templates. So you're welcome to use these and try and learn because that does give you control and understanding. But in the long run, you're not going to have enough people to maintain every tool that you ever get. So think about buy versus build. Here's the one for Python dependency scanning, SAST tools, and open source secrets using Git Leaks. If you click on them, you'll see that it basically has the stage, has some environment variables, and gives you the ability to kind of copy these into your pipeline and test them out. I also like to point out on our website, there is a 5-part series produced by Zach Thurman, one of my teammates. Great article that will show you how to build your environment. So if you're new to DevOps or DevSecOps, it's a great place to start and get an understanding start to finish in probably about a day or two. You'll have an environment up and running that you can test and build for free with the guidelines and step-by-step approach. So in summary, we talked about adding security to your DevOps pipeline. In the end, we also talked about buying versus building. I'm a fan of building, but I'm also a fan of buying when it comes to time. So you have enough information now to kind of make that decision on your own, and also enough tools to kind of get started. So with that, I'll turn it over to Tom. Thanks, everybody. Appreciate y'all's time.
Hey, thanks, Anthony. Appreciate the great demos. So again, if you guys missed the introductions up front, my name is Tom Wilson. I oversee professional services for CMG. And as CMG may be new to some of you, we wanted to give you a very brief introduction to who we are and what we do, and very brief as in 2 to 3 minutes, so this won't be long. At CMG, our focus is to find and build IT automation integration experts who are day one ready to deliver IT automation integration services and solutions. We have 3 core practice areas. 1 is DevOps, DevSecOps. 2 is machine learning, natural language processing. And the 3rd is cloud architecture and integration. It's our goal to be your go-to partner for IT automation integration services and resources. Our service offerings range from contract to hire to staff augmentation, managed services to custom projects and solutions. As you saw today, we can help you build or stand up a CI/CD pipeline from scratch that embeds security into it using both open source and commercially available tools. Or we can help you to continue build on that and mature that CI/CD pipeline to automate and integrate additional things that you may have already have in your environment. We also offer services like exploratory data analysis, or EDA for short, where we use machine learning and natural language processing to analyze data from your environment. We leverage data from your systems, such as service desk tickets, monitoring system alerts, or systems and application log, that identify patterns, trends, dips and spikes, and present opportunities for automation integration. We'll work with you to determine what the automation integration is that will drive benefits for your organization, such as greater customer satisfaction, increased revenue, reduced costs, and greater efficiencies. If you might be interested in having us perform an EDA for you, you can reach out to us. On our website, you'll find an I'm interested link under our service offerings area, and you can just click on that link and actually go directly to set up a meeting with us. So ultimately, when you need resources for DevOps, DevSecOps, machine learning, natural language processing, cloud architecture integration, whether your goal is to find a full-time employee or to fill a need for a consulting resource or services that you may need around these areas, we want you to think of us, to think of CMG. You can find more information about us by visiting our website, careermentorgroup.com. On the site, you'll find things like who we are, what makes us different, our service offerings. You'll also find our blog, our monthly newsletter on industry trends that you can sign up for. You can find previous webinars like this that we've had that you'll find posted on our YouTube channel. You can sign up and follow us there as well. You can even schedule a meeting with us just to discuss possible ideas if you have challenges that you face and just want to discuss them with us. And one of the things you'll find on our website under the terminology section that we have on our site is the DevSecOps terminology quick reference. It's a guide. It's actually quite long. It's just a table that'll give you the various terms, acronyms that you may have heard in our webinars and help you give you a basic definition of where you can go read more about it. Again, you can find that under the terminology menu on our site, and you'll find the DevSecOps terminology quick reference. We'd also love for you to follow us on LinkedIn. You can just search for Career Mentor Group on LinkedIn. You'll find us, or to connect to us individually on LinkedIn as well. And for those of you who are on the Twitterverse and enjoy a good tweet every now and then, you can follow us on Twitter. So with that, let me transition it back over to Jen.
Awesome. Thanks, Tom. So if you enjoyed the content today, be on the lookout for our upcoming artificial intelligence and machine learning crash course. It was initially scheduled in September, but we did push it out for December 9th, which you could still go to our website and register. And the last webinar in this series will be artificial intelligence and machine learning for cybersecurity, which will be January 2022.